You're right. Hello. Good morning. Oh my God. I'm having some issues with reflections today. It's kind of annoying. I'm wondering. Dag nugget. You see the text through my glasses. It's so annoying. I'm a little bit unsure how to fix this. Um. Oh, this is so annoying. Okay, so there seems to be like a sweet spot here. Yeah, like my nanoleaves, I have these nanoleaf elements, and I wasn't aware that they actually made that big of a difference. What's mask edges? Whatever. Okay, so yeah, so it seems like I just have more reflection now. I'm not sure why. Oh wait, this was the. You'll have to excuse me. You see the oop. So there's like this really sweet spot of. No wait, this is the light, and then this is the strength of the light. Yeah, no, yeah. Okay, so I definitely need this edge. Like that looks kind of weird, doesn't it? Uh, I don't know. Yeah, I think we have to try this. Yeah, let's just keep this for now. So at least there's no text going through my glasses. And let's get to it. So I was thinking, like, we were trying yesterday to do to use MobX with our new observable context, and that doesn't work. Like MobX needs to change because it's all based on wrapping functions, which is exactly what we don't want. But I built this library called Overmind.js a while back. And it's a state management library, and it has some similarities to MobX in the sense that you do mutation, which is really nice. And I think it's a more accessible API, especially with actions and stuff. You don't need to wrap things in actions or anything like that. It just kind of works. So I thought, what if we drop MobX and we rather bring in proxy-state-tree here? I can't remember now. Proxy-state-tree. Yeah, 3 years ago. Wait, was that the last publish? No, 2 months ago. Yeah, exactly. So that's 630. Is that the one? Yeah. So let's install that. I can't quite remember how to use it, to be honest. And we would definitely need some wrapper around this. Let's see. Yeah. So what we would want to do here. So we're going to try to just make the store return this tree. Just to see how it's working. Let's see. Use proxy-state-tree. Let's see. Did I? Where's the? No. Oh, what did I do? That's the one I wanted. Wait, what's wrong here? Oh my god. And a new browser tab. Count is nothing. And that's not too weird. Let's see. So let's do count 0. Yeah. So what it returns is the actual like proxy state tree here. Let's bring up the console. So what we kind of want to do here is use store. What was it? Let's bring this together. I have so much stuff open here. So yeah, we want to get track state tree and then dot state. So this is quite low level. And then we have get mutation tree. Okay, let's see what we can do with this. So what if we do like this? Does it show the countdown? Oh, that didn't work. Oh yeah. Oh my god. So this is not going to be any easier because we're returning the tree here. But now we are returning. Yeah, this is a problem. I'm not sure if this gonna. I don't think this abstraction is gonna work. The problem now is that we have this tree, and well, I guess we could. Okay, so we're gonna try something. No. Damn it. This is not gonna work. Because the problem is like we have to add the disposer, the symbol disposer, to the thing that's returned here. But we don't really wanna. Well, you know what? Maybe we can think about this in a different way. Yeah, you know what? Let's, okay, we're gonna think about this in a different way. So we're gonna do just return count 0 like this. And then we're gonna drop this. And then we have count 0. And now what we're gonna do is this will be like state, and then we're gonna return new proxy. So this is the only concerning part for me. Is like we're now creating like, yeah, but I think we can fix this. Yeah, I think we can fix this. So let's do return get track state tree state. So I think it should still be happy now. Yeah, it is. Cool. So we're gonna fix this by creating an abstraction over it. But let's see, where did it go? And then we have get mutation tree, which allows us to change it. So that means increase would be I'm just thinking about the abstraction we need here. So what's good about this compared to Overmind is that we actually have this function scope. So we can like keep subscriptions and whatever we want of like non-JSON types of things. And then we have so we're gonna try something. This count plus plus. That's what we're gonna do. And what we are gonna do here now is we're basically going to. No, would this work? Would this? I need some music. I need some 90s music. Because the way this is built, that you have one part that is the actual state tree, and then you have another part which is the actions you perform. And I think the abstraction would kind of have to be like, it would have to be something like this. Blah equals create store. And then you would have the actual store here. And then you could have like the actions on the next one. But the problem is now you don't have the scope anymore. What we could do instead, wait a minute. So what we could do instead is, okay, let's try something else. So we're gonna say new proxy state tree. So state would be new proxy state tree count 0. And then we would return okay, so we're gonna try something. So we're gonna say get what the hell are we gonna do here? And I thought I did something smart with this abstraction. Like, it makes sense to have this kind of abstraction, but it would probably be easier to like implement a new mutation based observable with this in mind. But now it's kind of weird. So the question is, I don't want to create, so I definitely want to return state here. And then, so what we could do here is like, mutation tree will be state get mutation tree. And then you could say like a mutation tree, was it dot state? Yeah. State dot count plus plus. So this looks super verbose and weird. But this will be state dot state. Yeah, this is super weird. But now the problem now is that we're returning So the thing is, we have this proxy state tree that we need a reference to. And we're gonna do get track state tree whenever we consume it in a component, and then we're gonna do get mutation tree whenever we start calling any of the methods. But that needs to be hidden. So it's almost like I have really no idea how to build this. This is kind of annoying. How would we build this? Think. My brain is a bit stuck today. Because, okay, ideally, like if even to do this, you would have to be able to do something like this. What should you be able to do? Like, I don't want it to be like a specific key you have to return. Like, it should just work. Damn it. Like, yeah, this really sucks because the whole point of this was to open up the scope so that you could have like other things. Well, I guess you could do something like store, create store. So you would define the state there. So here you would have like count 0, and then you would have increase would be this dot count plus plus. And then you could have like an optional scope for managing other things. But that's the problem. Like you want these actions to, maybe that's how you do it. So you kind of define the state as is, but then you have a callback for the actions. And by doing so, you give the actions a scope so that they can access. And you know what? We could even do like this state. Okay, this is looking like something. So it's not important to have a scope for the actual state because this is like serializable, like JSON. It should only be like JSON-like things. It's a single state tree kind of thing. But in terms of performing actions, and then you would also have like cleanup here. So like you could start a subscription, do cleanup. During the subscription, you can change this. Okay, this is what we're gonna do. This is the abstraction. This makes sense to me. So to do this, let's create that create store. And what it does is that it takes t extends like record. We're just going to do like a record string unknown for that. So that's the state. So that's t. And then we're going to have like logic callback or actions. And that's going to be, it's going to also take the state. And then this is going to return a record of, that also needs to be, let's call this S, oops. And this is going to take, so let's call that A, which record of string. Can I do function? I'm not sure if I can do function. I think I need to do params, any. I think I have to do that. Okay, so now we have, why doesn't it format, by the way? Did I type something wrong? Oh, record. Oh, so this should be A. Why don't we have formatting? Did I type something wrong? This is kind of annoying. Just try to refresh. Yeah, that's weird. Okay. So now we have this signature. Yeah, drop cleanup now. And what we're gonna do here, we're gonna create tree will be a new proxy state tree, and that would be state, and now we have that tree, and now we're gonna, now I have to think. Yeah, no, I think it's fine to just have a single mutation tree. So what we can do now is mutation tree would be tree get mutation tree. And then we can say actions equals actions creator. And then we say tree state. Oh, sorry, mutation tree.state. So now we're creating like a mutation, like this is how we protect it. So we're passing in a version of the state that you can actually mutate within that scope. So that's great. Now the question is, how the hell do we track this thing? So what we need to return from this thing is the tree and the actions, I think. And then now we know under the hood what we're returning from this. So then we can do use, let's say, remove this. Well, I guess we want to test it. So now we can say, what do we call this? Create store. Let's just call it use store. Now, and this is going to take, well, this is a problem. Like now we're actually, when we call create store, yeah, so what we need to do is, we need to return a function. Return, so this would take, and yeah, so this would take any props. This would be p extends record string unknown. So this would be any props, and then it's gonna create this thing. Yeah, this is interesting. So the props are coming from the provider, which means that like creating state. Yeah, so let's just put in the whole thing here. So this is gonna be props. This is gonna be props. And this is taking props, so we're doing props and then state creator. That's going to take props, and then we have tree actions. Okay, we're getting somewhere. So my store provider. What's this create store provider? Oh, I call it create. Oh, yeah, exactly. I didn't rename these yet. Let's see. My store would be, where's the store? Let's see, we're gonna get this. By the way, I have a meeting at 9:30. Yeah, so this also needs to be, well, a problem here is now this generic needs so ideally don't think that's too bad. Let's just try this first. What's kind of silly is that like you're doing a callback here as if you could like define something else in this scope, but you really can't. I wonder if there's somehow. No, we're just gonna make it work first. So then we have my store provider. So this will initialize the store with the props, and it will return. And then we're gonna call this use extended store, whatever. And this is gonna take this signature. So it's gonna take a proxy state tree and some actions. So this would be, is this what it returns? So yeah. So it needs to extend tree, proxy state tree, and actions, record, string, unknown. Well, params, any. Ah, now I have a typo again. Whatever. So it takes a record of params, any. There we go. So this takes. Let's see. Use extended store. Yeah, there's no type issue here because it's using taking tree and actions. And then what we should be able to do now is, yeah, I think this is like the props, doesn't matter. And now that we're using this store, what we get back here is the tree and the actions. So what we should be able to do is basically return state would be that tree get track state tree, and then we can just return the action. So you get like state and actions back. I think that's it. I don't super enjoy this signature, but yeah, let's see. Oh yeah, and now, so this my store. Oh, isn't it able to infer it? That's interesting. Anyways, oh yeah, because I'm, wait a minute. Thought it would be able to like count number. Oh, Yeah, whatever. My store state count actions increase. We'll fix the typing. Property. Oh, symbol dispose. Yeah, this is the big. We're still having the same problem because I can't like. Yeah, I think I. Oh, look at that. What the hell is happening here? Look, I'm all orange. Ugh, I have to fix this. Yeah, I think it's a weird lighting condition outside today. Anyways, we can't do this because this is the thing that gets the symbol. Well, we could just move the symbol along, I guess. Okay, we're gonna try that. So, how would we actually do that? How do you destructure a symbol? Can you do that? Or let's just do store. Why you're whatever, store result or something. And then we would have to do like symbol.dispose. Yeah, which is fine. Which is perfectly fine. There we go. Okay, so at least we have it kind of running. Now the question is, oh, this is interesting. Yeah. This is so we need to change this because we need access to this inside here, and we don't have access to that at the moment. Because we're calling this. So we use the result store. Okay, so we need to pass in the result store. Okay, we're just gonna hammer at this and see where we end up. So we're gonna pass the result store. So this would be T. So this would be result. So now we actually have access to the tree again. Oh, but we have a bigger problem because it's the get track state tree that we wanna. Yeah, but like this doesn't make any sense anymore because now we're. Yeah, like I didn't know how to introduce this, but I don't think this makes sense as a callback at all. Because the only thing it really does is well, it does ensure that we don't run multiple. Well, that's also interesting. Because here we actually do want to have multiple. Okay, so we're gonna say that we're not gonna do any of this. We're just gonna return the result store. Active store container. And then we don't need this. Okay, this is actually better because now we're not, yeah, and this doesn't have symbol dispose. We're gonna do, so this is only about getting the store, like injecting the thing. And then what we can do here is, so when we use the extended store, we'll get the injected one, right? But now we need to track tree. Okay, this makes more sense. Track tree.state. And what we want to do is track tree track. I'm not sure if it actually should have. Does this return like an untrack? And then we're going to do symbol dispose. So this is where we're going to stop tracking. I can't remember stop tracking. Yeah. Is this enough? No. Oh, of course. So the thing is, there's no way for us to, like, I think it's actually working, but we don't have a way to update the component. So basically what we need is kind of like a use state that basically just updates the thing. Let's see if it actually updates. Updated. No, that's not even happening. Are we actually changing the... Hey. Oh, nothing's happening. Oh, it is. Okay, so we are changing it. Okay, cool. And then we are updating the thing. Track tree. I'm just gonna see if it actually has the path. Wait, what happened? Path dependencies. Yeah, so it has a dependency to count. But for some reason that doesn't cause... we can check if we actually get a... Oh, we need to flush it. Yeah, exactly. This is very low level stuff. But what we can do now, we can do a very simple version of this. What is the very simple version of it? Okay, so we can do like on mutation tree on mutation console.log. Hey, so let's just see that it actually tracks the mutation. It does. So what we can do is like whenever it finds a mutation, we'll just flush the mutation. That should notify the updated. Yeah, exactly. So now this is actually updated, and I think we actually get a flush event. Oops. I think we get like a flush. Wait, array. Can't remember what we get there. Oh, we get a list of mutations. Okay. I thought maybe we would get the actual, but that doesn't matter. So the only thing we really need here is version, set version 0. So whenever we get like a new version, current, we don't really care about this. Oh, I can just do this. So this should make it work. Yeah. Creating a bunch of tracking trees. But the point is that it's working, which is cool. And we're using like mutation to make this happen. So this is kind of like Overmind, a new version of Overmind. So okay, so what would need to happen here to make this actually work? Yeah, maybe we could actually update Overmind to take advantage of this, because it would solve a lot of things with Overmind. Like the good thing about Overmind is its ability to do mutations, but it's like too declarative. Like you don't have any scopes to actually handle things like subscriptions and like cache, like other kinds of things that you don't necessarily want in your actual tree. But we are kind of enabling that here. I just don't quite like how it looks. And the point is that when you create, and also Overmind doesn't have nested trees. It's just one global tree. And this also fixes that. But what we can do is like reflect. So we know it's possible, at least. We know it's possible to make it work. It could even make it work with the debugger and everything, I think. Maybe like the debugger is based on a global tree, but you could like, yeah, maybe somehow deal with that. But I'm not like super happy about the way we introduce props. But I don't see any other way of actually doing that. What I also really like about this is like you have cleanup here. So you can think of this as your state and this as your logic. So in your logic, you can use any past props. You change the state and you can do any cleanup related to the store and mounting, which is really, really good. So it's conceptually good, I think. It's more of a signature thing. And maybe this is fine. So you can even argue that state should be the first argument here, because that's what you want to use for sure. And what I'm also curious about is, yeah, what's interesting about this is that, okay, so what if we rather do this? Const state, and then so what you could do is say props equals foo. Not sure why my computer is slowing down. Didn't we have this issue before? Anyways, so this is the props. So you say props and then count 0. So you say this is my state, these are my actions. Sorry, this is my state, count, number. And then you can say this is the state we're going to return. And then these are the props. This is the state. And then we're going to say increase. And we're going to by. And then we're going to say number here. And then we're going to say count plus equals by. So what I'm looking at here is like actions. Now, one thing we could do here is we could actually define. No, yeah, that's interesting because we already have derived here, which is interesting. So we can actually derive, so we can do this. Now, because discount, whatever. Oh, you know what? Another thing I like about this is that, yeah, we didn't talk about that. So if we do this, what we can do here, we can say, so you can say use other store. So you can use the store. It uses dependency injection instead. So you can just use other stores like this, and you can grab that state to like populate this state, for example. And you can of course do the same in the actions, which is interesting. That is also what the scopes enable. Okay, I'm starting to like this. And now we should, do we have actual typing now? No, I don't know why we don't have any typing, but that's something we can fix. Use extended store. Yeah, whatever. That's something that can be fixed, but this is an interesting thing. What if you were able to define your stores like this? A store can take some props, it has some state, and then you can define that state and you can use a callback to access the props passed to the store, and you can also inject other stores, parent stores. And then you define your actions, and they are the same. Like they get the props, they get the state of the store, and this cleanup. So you can do things related to the store and mounting. And you can also inject parent stores to if you need access to them. I do think impact is way cleaner though. Like it's way cleaner because you just have this function, you just define everything. So that's the thing. Like I think I would rather want people to understand impact, because the only thing reason we did this is because we want like mutation instead. But even impact, you know what we could rather do is we could create like a signal that is a proxy. Um, it could even be called store. And what it does is it just takes the keys of the object you pass in and makes signals out of them. And then whenever you access the key, you get like dot value back. Yeah, I think that's a better abstraction. So you kind of get the absolute benefit of, yeah, you know what? This was a fun exploration, but we're not going to do anything about this. Like, it's just this, it just makes me understand that this abstraction is really, really good. It's just a function. You can do whatever you want in it. The only thing is that it's like these primitives, they are like, it's a low-level primitive signal, but we could add a new primitive there called store, which is basically a proxy-state-tree. And then you could expose that as like state if you wanted to do that, and it would still just work. Yeah. And you could even argue that signal should be forced to be an object. That is interesting. Anyways, I need to go into, let's see. Yeah, I need to go into a meeting, but I want to do a stream where we create a new primitive for Impact React, where we basically call it store or something similar, where it can take a complex, like an actual object, and we convert the keys to signals. So it's kind of hidden. So that would remove all the need for like doing dot value, basically. Yeah, maybe that should be it, because that's the thing that gets people off here. It's like you have to access this dot value all the time. Like you don't have to do it in components, but that's because you're manually creating these getters. But we can get around that. Yeah, maybe that could be the big change, is that a signal always takes an object. Does that make sense? I think maybe it does. Anyways, that's something we can explore next time. Cool. I guess that's it. It's so interesting. Does it have? How do I? If I move the mouse, where's my head? Yeah, there. Does it take? Anyways, sorry. I need to figure out my lighting. Bye for now.